connection with a criminal case that happened a couple of years ago in Germany. A man that was called the Masked Man by the press killed several children until he finally got arrested in 2011. And when he was arrested, the police found a couple of encrypted hard drives in his possession. And the police was not able to decrypt these hard drives. Well, meanwhile, the Masked Man has been convicted to life in prison, so the case is solved, but the encrypted hard drives are still not decrypted, and so it's still not known what kind of evidence might be found there, and probably we will never learn. Let's now look at a second criminal case. This one happened here in the USA. You might remember the Anna Chapman spy case. Anna Chapman was a Russian woman living in the USA, and in 2010 she was arrested because of espionage. And again, in her possession, the police found a number of encrypted storage media. This time, the police was lucky in decrypting these files simply because Anna Chapman had written down her password on a piece of paper. And this is how the police finally solved the encryption, which means it was, of course, not a matter of code breaking, it was just a matter of luck. Well, if we are speaking about these two criminal cases, cases like these led FBI Director James Comey 1.5 years ago say something like, we need backdoors in encryption products. So the police, if they need access to encrypted files, it would be very helpful for them to have a backdoor in these products, and it would help police a lot. This is what James Comey said. But to be more precise, he was not really talking about backdoors, he was more talking about front door access to encryption products. So the question is, what is the difference between a backdoor in a product and a front door access mechanism in a product? Well, there might be some subtle differences, but in my view, it's pretty much the same. And so in my talk, I will talk about backdoors. I'm not going to talk about front door access mechanisms, and the differences will not play a role. So the question, as asked in the title of my presentation, is, do these backdoors make sense? Well, and now I come into play. My name is Klaus Schmee. Sherlock is my second first name. No, I'm kidding. But still, I wanted to find out, do we really need backdoors for the police in encryption products? And it pretty soon became clear to me that looking at two cases is, of course, not enough. So I tried to look at more of these cases, or I tried to assemble a whole collection of cases, which wasn't that easy because, of course, I'm only a detective. I don't have, I'm a private detective. I don't have access to police records. So what I had to do is check the internet. And this is what I did. So for about 4 weeks, I checked many websites, many search engines, and I was looking for criminal cases involving encryption, and finally, this is what I got. So it's a collection of 50 criminal cases involving encryption, all of them mentioned somewhere on the internet. I use pretty simple criteria for my search. If you want to look at the complete list, it's available online, and the criteria are pretty simple. I was looking for criminal cases involving encryption, and I was only I was only considering modern encryption. As I will point out later, there's a long and very interesting history of criminal cases involving classical manual encryption, a very fascinating topic. I will give you a little information about it, but this is not my focus today. I'm talking about modern encryption. And of course, the Masked Man case is a part of my collection, and of course, the Anna Chapman spy case is also a part of my collection. And let's look at one more case in my collection. That's the Susan Powell Mist case. Susan Powell was a banking clerk living in Utah, and she had a family, 2 kids and a husband, and in 2009 she suddenly vanished, and she has been missed since then. And the prime suspect was her husband, but her husband committed suicide a few years later, so this case is completely unsolved. And in the possession of her husband, police found a number of encrypted files. And again, police tried to decrypt these files, but it didn't work. They didn't find the password. And so what we have here is an open case with an unsolved case with unsolved encryption, and it will probably never be solved. And this is another case in my collection. We have looked at 3 cases. Altogether there are 50, so there are 47 more. Of course, I can't go into detail about each of them, but we can do a little statistics. Well, we have 50 cases, and the oldest one took place in the year 2001. And as you see, there were like 1 or 2 cases per year in the average until about 2012. And in recent years, we have a considerable growth. So the number of cases involving encryption seems to be growing. And as you see, in 2015, there are only 5 cases, but that's probably only because some other cases haven't been covered in the press yet. I'm sure this number is to grow. Still to grow, and I'm pretty sure that in the coming years we will have a further growth, and I'm quite sure that this will be a serious problem for police. Let's look at the offenses covered in my collection. 16 out of 50 cases are child porn cases, but there's also murder, terrorism, espionage, hacking, financial and drug offenses, and a few other things. And now it's pretty clear that the child porn cases are by far the most common. It's an interesting question why this is the case. Well, in my view, it's simply because most of the child porn offenders are simply familiar with using a computer, and so it's not really a challenge for them to use encryption. That would be my guess. And of course, child porn cases are more common than murder cases. That is certainly also a reason. Let's look at another statistics, the encryption products used. TrueCrypt was used in my cases. PGP also seems to be popular among criminals. And then there was the iPhone encryption functionality and a lot of other stuff. So as it seems, criminals use pretty much the same encryption technologies as ordinary people do, which comes to no surprise. And in 20 out of 50 cases, it is simply unknown to the public which product was used. And I'm quite sure this is because the police doesn't want to talk about the products that baffle them. TrueCrypt is the most common among the ones we know. You might know that the development of TrueCrypt has been abandoned about 1.5 years ago. But meanwhile, there are successor products like PC Play or VeraCrypt, and I'm pretty sure that many criminals will switch from TrueCrypt to VeraCrypt or a similar solution in the near future. And now let's look where these cases happened. 25 of them in the USA, 2 in Canada. There's also the UK, Germany, and a few other countries. Well, this statistic is certainly biased because, well, I speak English and German, so I mainly checked English and German websites. There might be other cases in the Spanish-speaking world, but I don't speak Spanish, so I didn't find them on my Google searches. So if you know a case that has happened in Spain or in Italy or wherever, just tell me. This is a very interesting statistic. The question is, how did police retrieve the encrypted data we are talking about? Well, in 50 out of 50 cases, the police confiscated a device, like a laptop or a PC. And in 0 out of 50 cases, the police eavesdropped mail or phone traffic. But quite interesting, because I would have thought that phone and mail surveillance would have played a more important role. Maybe it has, but maybe the police doesn't like to talk about phone and mail surveillance. Maybe they say, well, talking about confiscating devices is okay, but talking about phone and mail tapping is not okay. That might be the reason for this statistics. If you know another reason, tell me. And now this is, of course, an interesting question. Was the police successful in solving the encryption? And in 33 out of 50 cases, the police was not successful. But in 11 cases, police was successful, and there are also a few cases where it's not clear, or only the police was partially successful. So it's pretty clear that in most cases, the police lost. And this is certainly one of the reasons why Comey wants to have backdoors in encryption products. Now you might ask, well, in 11 cases police was successful. Can they really break modern encryption? And I think they certainly can't, but they sometimes can bypass encryption. I think Ali Shamir mentioned this yesterday in his keynote talk. Modern cryptology isn't broken, but it is bypassed in some cases. I will give you a few examples. For example, I was talking about the Anna Chapman spy case, and Anna Chapman simply wrote down her password on a piece of paper, and this is how the police broke the encryption. Well, it wasn't broken, but it was bypassed. Well, let's look at this case. You might remember the Robert Hanssen spy case. Robert Hanssen was one of the most important spies in US history. He sold a lot of classified data to the Russians, and he used an encrypted PDA, personal digital existence. And while this PDA was unlocked and left unattended on his desk, an FBI agent was able to copy all the content of this PDA, and so the encryption was bypassed in this case. Or let's look at the Justin Gerard Gribba case. Gribba is a Canadian child porn offender. In this case, police needed 2.5 years to finally break the encryption or to find the correct password. And now you might ask, how was this done? How could police find a password in this case? How did this 2.5 year long attack work? Well, the details were never published, but it's pretty likely that it worked the way I will explain now. First of all, we need to look at how an encryption product works. And I'm talking about an encryption product not involving public key cryptography or public key infrastructure. Instead, we assume that the key is derived from a password. So we have a clear text, a password, an encryption algorithm, and the first step of the protocol is to use a hash function or hash algorithm and derive a key from the password. The second step is that the clear text is encrypted with this key. The result is the ciphertext. But this isn't all. Now in the third protocol step, the so-called key check string is encrypted. The key check string is a non-secret information, and it's encrypted with the same key as the clear text, and the result, the encrypted key check string, is concatenated with the ciphertext. And now, the decryption process just works the other way around, but before a decryption can be performed, the program checks if the key provided is correct. And so we have a password candidate, that's a password provided, and now, before doing any decryption of the ciphertext, the program first of all derives the key with a hashing function, and then only the encrypted key check string is decrypted, and then it is checked if the result is correct. This check can be made because it's a non-secret information. And this is how the correctness of the key is checked, and of course this can also be used by the police when they are searching for the password used. If we look at TrueCrypt, this key check string is used a little different, so the concept is the same, but I just wanted to show you that it's a little more complex in practice. In the case of TrueCrypt, we have a volume header that's at the start of every encrypted data file. And this volume header, of course, contains information like the TrueCrypt product version and volume length and other metadata. And there's, at the start of the second block, there's a 4-byte string spelling the word true. As I said, it's non-secret information. In this case, the non-secret information is the word true. And the second part of the key check string is a checksum. So the second half of the header is a checksum is computed, and this checksum, which has 4 bytes, is the second part of the key check string. This is how it works in TrueCrypt, and you get the concept. It's exactly the same as on the slide before, only that we have divided a 2-part key check string. And now what the police can do, if they know the encryption program and they know the key check string, they can check one password candidate after the other, probably taken from a dictionary. That's why it's called a dictionary attack. And one password after the other is checked until finally the correct one is found. This is how the police probably worked in the Gribber case, and in the Gribber case it took 2.5 years to finally find the correct password. Now the question is, well, what happens if the specification of the program is not known? Of course, the specification of TrueCrypt is known because it's a public domain program, but what happens in the case of the iPhone encryption functionality? That one isn't known in detail. So in this case, often only the producer can start a dictionary attack. And if the producer isn't willing to, the police certainly has a problem. And you know that a problem like this at the moment is in the media, and talking about the San Bernardino shooting case. In 2015, in December, there was a shooting in San Bernardino, California. I think 14 people were killed, and the perpetrators were killed too. And one of them had an encrypted iPhone. Police couldn't solve the encryption, so they turned to Apple and asked them for help. They got some help, but not the help they actually were looking for, the help they needed for a dictionary attack. So the question is, could Apple create a tool that performs a password case search for this case? And well, for the answer we can ask Tim Cook himself. Here he is. Well, he said, yes, we could create such a tool, but it's something we believe is too dangerous to do. The only way to guarantee that such a tool isn't abused is to never create it. And this is the dispute that is going on at the moment. And well, we'll see what happens, if Apple will finally assist in this dictionary attack or not. Let's see. And you might know that Donald Trump also gave a comment on this matter. Donald Trump said, boycott all Apple products until such time as Apple gives cell phone info to authorities. Well, I think most people in our business have a different view, but this is the view of Donald Trump. Now the next question, well, what happens if the user uses a password the police can't guess because it's not in the dictionary? Well, a stupid question. Of course, in this case, it won't work. The password will be never found. And what happens if the key is stored on a smart card instead of derived from a password? Well, then the attack won't work either. So the next obvious question is, are there any criminals using smart cards for key storage? And at least in my collection, this is not the case. In 50 out of 50 cases, the criminal used a password to derive the key, and in exactly 0 out of 50 cases, the criminal used a smart card. Interesting result in my view, but it might change in the near future. And I think replacing passwords is an interesting or very popular topic here at the RSA conference. We might see criminals who will change their key derivation method in the near future. And now I have have to admit that there's one thing I don't understand myself. If the police can break an encryption, why don't they ask the public for help? They could simply publish the ciphertext or whatever and ask code breakers in all the world for help. So maybe it's because they don't want to publish the ciphertext, but I don't think this is the real reason why this never happens, because, well, first of all, it has happened before that the police publishes ciphertext, and second, it's not even necessary. Well, let's look at the first statement. It has happened before that the police publishes ciphertext related to a criminal case. Yes, for example, a couple of years ago, this happened in the Ricky McCormick murder case. You might remember this one. Ricky McCormick was a man who was found murdered on a cornfield in the state of Missouri. And he was murdered. Police couldn't solve the case, but in his pocket, the police found 2 encrypted notes. And as you see here, this is not an example of modern computer-based encryption, but we are talking here about manual classical encryption. This was found in 1998. 13 years later, the police decided to publish these 2 encrypted notes, and in the last couple of years, code breakers in all the world could look at these encrypted notes and try to break them, but it didn't happen. So if you want to solve a murder case from the sofa, this is what you can try. I'm not going into detail, but I just wanted to mention that it happens that the police publishes ciphertext. There was let's go a little more back in history, there was a similar case in 1948 in Australia. A man was found on the beach in Adelaide, Australia, and well, he was dead. It's not clear whether he was murdered or if it was a disease or if it was suicide. And the interesting part about this case is that this man was never identified. So I think the picture that is available of him is quite good, so it should be possible to determine who this man was, but it hasn't worked in the last 70 years. So the man has never been identified, but it was found out that soon before his death, he carried this note with him. It could be an encrypted note, could be a cryptogram, could be anything else, but in the last 70 years, nobody has found out what these letter sequences mean. And again, you can try if you're a good code breaker, maybe you will find something. And again, it's a case in which the police has published ciphertext. Well, let's look at one last historical case. This took place in the 19th century. In 1882, a stranger named Henry DeBosnis appeared in Essex County in the state of New York. And he immediately started courting a woman named Elizabeth Wells. And after only a few weeks, the two married. But the marriage didn't last very long, because after a few months, Elizabeth DeBosnis was found murdered. She was stabbed and killed and shot. And of course, her husband was the prime suspect. He was immediately arrested and put into jail. And while in jail, he started creating encrypted notes. So he created 4 long cryptograms. And well, I will come back to these later. He was then put on court, and in 1883 he was convicted to death, and then in the same year he was hanged. But there remain a few open questions in this case. Well, first of all, it's not absolutely sure that he was really guilty. He probably was, but if we talk about the death penalty, a high probability is certainly not enough. And another question is, did he murder his first 2 wives too? That's well possible, because he had 2 earlier wives who both died in a young age. And the final question is, who was he anyway? He said himself that Henry DeBosnis was not his real name, and that he was living on a wrong identity, but he never revealed what his true identity was. So there are many questions about this case. Some of them might be answered if it was possible to solve the cryptograms that DeBosnis left behind. They are 130 years old and still unsolved. So again, this is a case that is unsolved with an unsolved encryption, and police publish the ciphertext but without success. Well, but let's now go back to modern crypto. I said that it's not necessary for police to publish the ciphertext if they want to ask the public for help. So why is this not necessary? Well, if you look at this algorithm I showed you and how the police can guess the password with a dictionary attack, you see that only the encrypted key check string is necessary. So the police need not publish the ciphertext, it's enough to publish the key check string. And I don't know why this has never happened in these cases I was looking at, so if you know an answer, please tell me. Next question, can police force a suspect to reveal his encryption password? In some countries, police can. For example, there are key disclosure laws in Australia, in Canada, in India, in France, and UK. But there's no such law in the USA. But still, it has happened, based on some other laws, that police or their judges have forced suspects to reveal their passwords. Some people say that this is a violation of the Fifth Amendment of the US Constitution. This Fifth Amendment says that nobody can be forced to be a witness against himself, and the question is it an act of being a witness against myself if I'm forced to reveal my password? This discussion is going on, and we will see what will happen in this question. Now let's look at another statistic. Who used encryption? Well, in 48 out of 50 cases, it was the suspect who used encryption, and in only 2 cases, it was the victim. But it's important to note, sometimes it's the victim who uses encryption. For example, in the Brittany Mills murder case, Brittany Mills was murdered, and police found an encrypted iPhone in her possession, could never break the encryption. Or there was a similar case in 2015 too. A man named Ray C. Owens was shot, and in his possession the police found even 2 encrypted smartphones, an iPhone and a Galaxy. And so it's important to know it's not always the suspect who uses encryption, but sometimes it's also the victim. And now you might say, well, all the stories I've told you so far are quite interesting, but the main question is, how often did encryption keep the police from solving a case? And difficult question, but we can look at the statistic of the case status. In 11 out of 50 cases, the police solved the encryption, so backdoor wasn't necessary. In 25 cases, the police solved the case without solving the encryption, so backdoor wasn't necessary. In 4 cases, the case is still pending, but probably it will be solved, so these are probably also 4 cases in which no backdoor will be really necessary. And only in 3 out of 50 cases, the police could not solve the case and could not solve the encryption. That means only in these 3 cases, backdoor would have been really crucial. And there are also a few other unclear cases. But it means only in 3 cases a backdoor would have been really crucial, but of course it would have not been a guarantee. Maybe the encrypted information in these cases would be completely helpless for the police. It's only a possibility, and I think that's a very important result of my research, as it seems in only 3 cases a backdoor might have been crucial, so a backdoor is certainly not a magic bullet. That's one important statement I wanted to make today. James B. Comey was also talking about a few cases. For example, he mentioned a Louisiana sex offender case, child abuse in Los Angeles, drug offense in Kansas City, Sacramento murder case. All these cases are not on my list because in these cases the suspect didn't use encryption. So Comey mentioned these cases because they involve digital data, and if the offender would have encrypted the data, it might have kept the police from solving the case. This is a speech James D. Comey gave in 2040, but immediately after that his claim was disputed. There were people saying that only one of the 4 cases that he mentioned in his speech was really solved based on this digital data, and only this one out of 4 cases would have been one in which the police might have been kept from solving the case because of encryption. There's another case I would like to mention at this point. This one took place in Germany. In Germany in the 1990s, there was a kidnapper named Thomas Drach. He kidnapped a German industrial person, Jan Philipp Reemtsma, and the kidnapping was successful, and with the money he escaped to South America. From South America, he talked to a friend in Germany on the phone. He didn't use encryption, of course. Police eavesdropped all of these phone calls, but he never revealed the place where he actually was. This lasted for a few weeks until finally he once said on the telephone, "Tonight I'm going to watch the greatest rock band of all times." And then the police checked on the internet and they found that the Rolling Stones played in Buenos Aires that day, and then they knew that he was in Buenos Aires. They also knew that he tended to stay in luxury hotels, so they checked the luxury hotels in Buenos Aires. And so they found him on the same day, only a few hours after this telephone call. So it's clear, in some cases, in some cases, encryption really can prevent the police from solving the case. There's another question. If there are backdoors in US crypto products, people still can use foreign products. This is something that was addressed by Bruce Schneier recently. He recently published a survey. So if you want to know what's in this survey, just listen to Bruce Schneier himself. He said, well, the result of his survey is there are at least 865 products incorporating encryption. This includes 546 encryption products from outside the US. And his conclusion is, anyone who wants to avoid US surveillance has hundreds of competing products to choose from. Now the question is, does this make backdoors completely useless? Well, in my view, it doesn't, because we all know that IT users are pretty lazy when it comes to encryption, and most people, if they use encryption at all, they simply will use what is pre-installed or what they get on an app store. So it's certainly nonsense to believe that every criminal in the world will tend to non-backdoor products from other countries, but this will considerably lower the value of backdoors. And what about steganography? Well, there's one steganography case in my collection. In Germany, terrorists hid information about a planned cruise ship kidnapping in a porn video, classical case of steganography. And so, again, we can say, of course, there will be criminals using steganography, even if only backdoored crypto products will be on the market. Of course, not every criminal will do this, but again, this will lower the value of a backdoor in an encryption product, because everybody can simply use something else. Okay, so let's bring all the people I mentioned back on the stage. And let's ask, what is my conclusion? Well, first of all, I looked at 50 cases. In some cases, the encryption was broken. In some cases, the case was solved without the encryption being broken. In some cases, the case would not have been solved even if the encryption was broken. Some suspects certainly would have used foreign products without backdoor if we had backdoors in the USA. And some suspects certainly would have used steganography. So in the end, only very few cases remain in which a backdoor would have been absolutely crucial. I think in about 1 or 2 cases out of 50. So backdoors should not be overestimated, and it should also be clear that backdoors have disadvantages. And now you might ask, well, I'm German, so you might ask, what do we in Germany think about crypto backdoors? So my answer is, we Germans only can recommend the US to introduce crypto backdoors. Why? Well, they will perfectly help us to sell our German crypto solution. Well, I'm kidding, of course, but this is certainly one reason why backdoors are certainly why many people don't want backdoors here in the USA. There are, of course, other reasons. For example, backdoors can be abused by the authorities, they can be abused by hackers, they can be abused, they limit our freedom, and backdoors criminalize people who want to use non-backdoor products. Well, there are a lot of problems with backdoors. That's not the main focus of my presentation, but it should be clear that these problems exist. And so if you finally ask me, does the risk of criminal activity justify a ban of strong encryption? Well, that's the title of my presentation. The answer is, I think no. Of course, backdoors are not useless. There will be some cases in which the police might profit from backdoors, but as I said, there are not too many of them in my collection, and so it's absolutely justified to say backdoors might be helpful in some cases, but the price we pay for them is too high. Thank you.